Hi, the section 5.2, the dispersed Poisson model. So the Poisson model basically has only the one parameter mu. So remember that the linear model that we have, okay, so y is equal to x beta plus epsilon, and the expectation of y is the x beta, and the variance of y is equal to sigma square. So we have different parameters. So if we say the x beta as mu, then we have basically different parameters for expectation and variance. But the Poisson model, it's similar to the binomial model, and the expectation of y is equal to mu, and the variance of y is equal to mu. So the same parameter dominates the both quantities. So sometimes that we lack the freedom to express the expectation and variance more flexibly. So yeah, this is similar to the binomial case. The binomial case, the E of y is equal to P, and the variance of y is equal to the P times 1 minus P. So the specifications are different, but anyway, the one parameter dominates both. Yeah, so we also think about the over and under dispersion model for the Poisson regression. So it's similar to the dispersed, the binomial model. So there are some causes of the over or under dispersion. So one is the outliers. So basically data are not correct. And the another reason is the predictors are not sufficient, or the model specification is wrong. For example, that we are missing some predictors, or when we regress the y on x, but that should be y on x and x square. So specification is not correct. And the third reason, okay, so this is the second reason. And the third reason is the assumption of Poisson distribution is wrong. So Poisson distribution assumes that basically we approximate the small probability with the large population, but sometimes the different part of the population have different success probability and so on. Or if we think about the so the Poisson random variable as a sum of the events with the random interval which follows exponential distribution, then maybe the interval is not really independent. Intervals are not independent, then the Poisson assumption is not correct. And for this third case, that we can improve the model accuracy by either introducing a dispersion parameter or develop another model with more parameters, such as negative binomial regression. So here we study the dispersion parameter. So this only adjusts the standard errors of the regression coefficients. So it doesn't change the model itself, but at least we have more accurate evaluation on the testing or significance of predictors. Yeah, so to be exact, that we assume that the expectation of y is equal to mu, and the variance of y is the phi times mu. So here is typo, so this is mu, phi times mu. So the over dispersion model is an artificial adjustment to the variance, so does not try to identify the true distribution of y. So just the two parameters are more flexible than the one parameter. So that is the idea. And when the expectation of y is mu and the variance of y is phi times mu. So we don't really specify what's the exact distribution of y. And the phi is variance divided by expectation by the definition here. So the phi is estimated by this quantity. So basically the mu hat is basically estimate for expectation of y I, and the yi minus the mu I hat square. So this is basically one estimate or maybe one realization of the expectation of yi minus expectation of yi square. So this quantity. So if we take the average, the overall observations, and we adjust the degrees of freedom, so here P is the number of parameters. So if the mu is equal to x beta, then the beta is the P dimensional vector. So if we use this phi, then we can phi hat, then we can estimate the phi. So this is the estimate. So this is the basic idea of the dispersed Poisson model. In the next video, we discuss an example.